Hello, my name is Ivan Fernandez, and I would like to introduce our final code review and demo. This is the Identify and Describe section. Our project was number 25, the eval board support for the Arduino IDE. Team members involved were Elliot Sloan as the product owner, myself as the Git master, Jemima Thomas as the communications master, and Paul Duncanson as the scrum master. Our sponsor is Bob Martin, and we worked closely with him and Microchip. The entire goal of the semester was to continue adding IDE functionalities for two specific Microchip ports. And these are the AVR 128DA48 and the AVR 128DB48. Part of the motivation here for this project was to create a functionality for the boards within the Arduino IDE. This benefits a lot of groups of people, specifically educators, hobbyists, and the startup community as a whole. The team used a fork of a third-party repo from GitHub, and this repo is owned by Spence Conde. We forked the repository to gain basic knowledge of the structure of the core that we were to develop for each of the boards. This is the DX core. Our repository, forked from Spence Conde. We learned to create a boards.txt file that gave functionality to each of the boards with specific settings within the IDE. Our sponsor decided upon the settings that were ideal for the target audience. This is the IDE here, loaded with our core, and here are the options that our sponsor decided were ideal for our core. Thank you.
So this is the formulate section, and we're going to be talking about the ability to identify, formulate, and solve complex engineering problems by applying principles of engineering, science, and mathematics. Essentially, it'll be how we planned out how to tackle the problems posed by our sponsor. And this is demonstrated by the use of backlogs, sprints, and user stories, and how we decided to test the new hardware and software across different operating systems in AV fashion. So to begin, we'll talk about the sprints. So, and this is how we did it, essentially. So sprints 6 and 7, here you have, we figured out how to create a package on Ubuntu, which is left over from our previous sprint actually, and how to incorporate the latest version of the DX core into the Teams package. We decided to better delve into how Python and Arduino interact, and that required us to learn how to use a different IDE. That was a separate task that we added as well. We also decided how to change the compiler flag system so that we could set custom inputs into the compiler. And this is the IDE MPLAB X that we had to get familiar with in order to better understand the relationship dynamic between Python and Arduino. Also, we continued to modify the original core according to sponsor feedback, so this often was maybe miscellaneous changes that needed to be completed. Okay, and then here in Sprint 8, we received new hardware. The DB48 was among this, and we also received the servo. And we needed to test the functionality of this new board into the team package, and then test the servo examples that were provided as part of the default. So we tested the servo across the different provided examples, knob example, servo max test, and more. We took a thorough approach to how we planned our tests, and I'll show that later in the video. And here we also wanted to add the DB48 functionality to the core package. So this included updating a lot of the JSON files, et cetera, and updating the menu system so that DB48 functionality was available in the IDE. Then we updated the core for the DB48. So it wasn't just talking about the user interface, this was backend also. So this setting default clock speed, et cetera, the settings, et cetera, via boards.txt. And we decided to continue testing the DX core servo examples to make sure we had a concrete understanding of how the servo worked. And lastly, moving into sprints 9 to 11, we found and fixed, finalized any issues with the IDE default examples. We tested more hardware on the DA48 and also on the DB48. And we finalized the boards.txt settings and the pin mappings as well. So here it is, fixing IDE examples. We went through step by step the different IDEs and any of the issues we noted from our previous testing and decided to fix it in this iteration of sprints 9 through 11. We continued to test the GY521 examples also for the DA48 and the DB48. So this meant going through the different tests and also meant writing our own tests for both the DA board and the DB board. And lastly, we attempted to create a final version of boards.txt that contained all of our settings. And we double checked that the settings we were creating were being sent to the compiler. And then lastly, we also fixed the pin mapping diagrams for the DA and the DB. So this was a accumulation of our tests from previous sprints. So any issues we noticed with the pin mapping that were provided to us, we fixed and generated new PNG files as designs. Last but not least, jumping into how we did the testing. This is an example of how we organized our examples. So essentially, we tested if it compiled. We went back and tested the different hardware functionalities that we received in this iteration of 402. And that is how we organized and formulated how we tackled the problem.
Hi, my name is Elliot Sloan, and I am presenting the user perspective part of the solution for our final review. For the purposes of demonstrating this, I have installed a clean install of the Arduino IDE, which I'll be opening up right now. Okay, so here is what the user would see when they first open the Arduino IDE. And now we are going to download our Teams package we created. So currently it's hosted on our GitHub, but by the time the project is completed, we'll probably have it posted somewhere else. For now, you would just copy this link, go to Preferences within the IDE, open up the board manager and paste our URL in. Push OK. Push OK again. Then head over to Tools, Boards, and Board Managers. You can see it's downloading Platforms Index. It's looking at all the packages it could possibly download now that it's updated. We'll go ahead and make this a bit easier to find, and we'll filter by contributed. There's our core, Team 25 core by the ASU Capstone Team 25. We'll click Install. You can see installation's completed, so we can go ahead and close this. And now, if we go to Tools and Boards, we can see that there is a subsection for Microchip and for the AVR DA series, which is the board that we've currently supported. So we click that. And we see some more options. We have a chip selected, currently now only the DA48. Eventually we will have the DB48. And we will select a programmer, Curiosity Nano. Then I'll plug in my board and we will upload a sketch. Okay, so now I've installed the Micro DA48, and I will go ahead and load a sketch. So we'll go ahead to the Examples tab, Basics, and Blink, a classic sketch. And it opens up a new window. We will click Upload, and down here we can see how compilation is going. Okay, so there we can see that the sketch compiled and uploaded, and here's some of the output from that. And then on the user side, you will see that the LED on the Curiosity Nano DA48 is currently blinking. And that is a demonstration of the user side, user perspective of our solution. In the future, a user will be able to download that package, and it will include more boards. During the second part of our capstone, we plan on including at least one more board, the DB48, and because we are seemingly on track and a bit ahead of schedule, there's likelihood that a few more boards will be added. Also, we plan to finish and create a series of Markdown documents that would allow users to create their own packages in the future, and the Markdown documents would provide some instruction for that. Thank you.
Hi, my name is Paul Duncanson, and today I want to talk to you about Team 25's engineering practices. We demonstrated engineering practices through the creation of a JSON file, through our microcontroller core package creation, through the menu system upgrade we did, through setting compiler flags in specific ways, and through pin map testing. Pictured on screen is the Teams JSON file, which was created as a way of interacting with the IDE and the core that we created. The tools section of the JSON file will download extra tools that are necessary to get the core package running with the microcontroller through the IDE. Originally, our sponsor preferred to have 0 tools to lower the overhead of the overall package, but we encountered issues during the second semester that we needed to actually add a new compiler because one of the newer boards we were working with was not supported by the default Arduino compiler. So we had to test and find out what was going on, and eventually we discovered that we needed to add the AVR-GCC compiler to our tools package, and now we have to load one tool as we download the core package into the IDE. On screen you can see the repository that holds the core package that was originally created by our team. The JSON will direct the IDE to go to this URL and download the core package from here. The basis for this package was the DX core made by Spence Conde originally, and our team modified it to basically streamline the user interface and a lot of different aspects of the core to focus more on what our sponsor Bob Martin of Microchip wanted to accomplish with the core. The original DX core contained a lot of extra boards and overhead that was unnecessary for our current core that we created for the 2 microcontroller boards that Microchip sent us. Through a multitude of tests, the team was able to discover what elements from the DX core were critically important and needed to be included in this version of the core to be able to fully function with the 2 boards. The original DX core contained thousands of menu options within the structure, and our sponsor felt that this was completely unusable for a beginner or medium level Arduino user and wanted the team to come up with options that he could look over to create a user-friendly experience for beginners. To give our sponsor the options that he could have within the menu system to see different visual styles that might be appropriate for what he desired, the team redesigned the boards.txt file, as you can see, which is this file basically sets all the menu options, how they look, and all the variables behind the menu options within the IDE system. So redesigned it to be able to comment and uncomment different sections that will then generate the menu system differently, and visually it'll look different, but it'll do basically the same thing, and this would allow our sponsor to decide which one he liked the best. And we ended up having 5 different options. Some are longer than others, but that's just what you had to do to get the menu functioning properly and visually different than other options. And here are the 5. Compiler flags became an issue later in the project. As you can see, when you upload a sketch to the board, compiler flags are set for the variables you chose in the menu structure and in the background of the project. And what became an issue is that with another IDE that Microchip created, other than this Arduino default IDE, the compiler flags from our package weren't being set correctly, and we had to fix that as a team. Discovered through researching the problem is that the compiler flags set in the menu structure here in boards.txt are not set in the other IDE because they don't have the same menu structure or function the same way as in the default Arduino IDE. This means that we as a team had to move the flags into the board platform.txt file. As you can see, these flags are being set automatically here without having to make a choice back in the IDE menu structure. These will just automatically be sent up to the compiler when it throws the package together and uploads to the board. Pictured on screen is a pin map diagram for the DA48, one of the boards the teams was assigned, and it was our job to figure out if this pin map was accurate. The difficulty with testing these pins is that some perform multiple functions. The team broke the pins into different sections, and each member took different portions of the board and tested for the different functionality within each pin. This systematic approach to testing each pin has led the team to have confidence that the product that they delivered to their sponsor is functioning properly, and our sponsor is satisfied with what we've delivered. Thank you for your time.